Okay, this is the free response portion for the exam 2, physics 102, spring 19. What is the voltage on C1? That's this capacitor right here. Well, first, let's just redraw this circuit. So I have C1 there. I come along here, and I come here, and then I break into two branches. And in those two branches, I have C2 and C3, and then they come back together right here. It's like I can collapse this whole line down to a point, and then it comes back and it breaks down into three branches. Then once I see the circuit like this, I know, hey, this isn't that hard. It's fairly straightforward. I have a 2 microfarad capacitor here. I have a 1 and a 2. Not ohms. 1 microfarad, a 2 microfarad, and then I have a 2, 1, and a 3. And I want to know what is the voltage on C1. Well, to do so, I'll need to find the equivalent capacitance of 12 volts there. And the equivalent capacitance is going to be a 2 microfarad, a 3 microfarad, and a 6 microfarad. All in series. And I got that, of course, by saying 2 plus 1 is equal to 3. 2 plus 1 plus 3 is equal to 6. That's how I find the equivalent of capacitors in parallel. And now to find the equivalent of this, I say 1 over 2 plus 1 over 3 plus 1 over 6. That's 3 6 plus 2 6. That's 5 6 plus 1 6 is 6 6. So that's equal to 1. So I have 12 volts with a 1 microfarad capacitor. And I say, what is the charge on that 1 microfarad capacitor? Well, it's C times V, so that's 12 microcoulombs. I know that capacitors in series all have the same, where's my color? Oh, capacitors in series all have the same charge, so then I know that I have 12 microcoulombs here, 12 microcoulombs here, and 12 microcoulombs here. And then I can find the voltage, because V is Q divided by C. So that's 12 divided by 2 for that first one, are 6 volts. So I have 6 volts here, 4 volts here, and 2 volts here, which is good because 6 plus 4 plus 2 equals to 12, as it should. And then that gives me the voltage for this capacitor. The answer is 6 volts. Now, the current through the rightmost 2 ohm resistor is 1 amp upwards. That's this one. I have 1 amp. And I want to know what is the magnitude and direction of the current through the middle 2 ohm resistor. Let's say I'm just going to label this circuit as I2, and I'll label this one as I1. Although I don't need I1, we'll see. Now, if I want to find out what is I2, notice that since I know this current over here, I really just have to use this right loop and write the loop rule properly, and then I'll be able to solve for I2. So let's do it. I'll start right here, and I'll go in this direction. So that's minus 4 volts, minus 2I2, plus 2I, we'll call this I3, is equal to 0. But I know what I3 is equal to 1, so I get minus 2 I2 equals 0. Now look what I did there. I put in a 1 right here, and then I added this 2 to the negative 4 to get negative 2. And then I solve for I2. I2 is equal to 2 divided by negative 2, or that's negative 1 amp. And so my answer is 1 amp, and it is in the downward direction. 1 amp down. The reason it's down is because I chose it to be up right here. I didn't really have any reason for choosing it to be up. I just chose it. But because this came out negative, that means that I chose it incorrectly. And you might have done it a little bit differently. Maybe you chose the direction correctly because, you know, you're just better than me or whatever. But if you did that, you would have gotten a positive value there for the 1. Okay, let's find the equivalent resistance of this circuit. So I know that these two together are 6 ohms. And then I also know that these two together, 1 over 3 plus 1 over 6, that's equal to 2 ohms. So that's 2 ohms. So I'll go ahead and redraw it with those in mind. So here's my 2 ohm resistor, 6 ohms, and then I have a 2 and a 1 ohm. 2 ohms, 6 ohms, 2 ohms, and 1 ohm. And that's all a 12-volt battery. And I want to know the equivalent resistance. The next step would be to combine these two. That would be a 3 ohm. I'm just going to draw all this out. You don't really need to do this to find the equivalent, but it will help us in the next one. So this is 2 ohms, 6 ohms, 3 ohms, 12 volts. Oh, but we already done the 6 and the 3, so I'll just go here, 2 and 2. The 6 and 3 in parallel is a 2 ohm, and so the equivalent is 4 ohms. So that's my answer, 4 ohms. And now I want to find what is the current through R4. That's the current through this resistor. I'm going to do this in blue. So to find that current, I first find out what is this current. Well, that current is 3 amps. That's 12 divided by 4, V over R, is equal to 3 amps. So if I have 3 amps here, that means I have 6 volts here and 6 volts here, because I have 3 amps on both of the 2 ohm resistors. Or you could have just said that, hey, I have identical resistors. They have to split this 12 volts identically because they're the same, and that would be fine. So I have 6 volts here, and that means I have 6 volts here and 6 volts here, because those two are in parallel. They have the same voltage, and they have the same voltage as their equivalent resistor. That's that 2 ohm resistor. And then, let's see, what am I looking for? I'm looking for the current on R4. If I'm looking for the current on R4, I got to step back a little bit more. So I have 6 volts here and here. That means I have 6 volts here, 6 volts here. And then these two resistors have a shared 6 volts. They share it. They don't share it equally. But I know that that 3 ohm resistor has a current of 2 amps. So I know that I have 2 amps through each of those resistors, because I is equal to V over R. That's 6 over 3. So I have 2 amps in the 2 ohm resistor and 2 amps in the 1 ohm resistor. That gives me a voltage of 4 volts and a voltage of 2 volts there. So I have 4 volts and 2 volts there. That means that across R4, right here, I have 4 volts. So V is equal to 4 volts. R is equal to 3, so I is 4/3 amps for R4. All right. Now let's move on to the multiple choice part of the test. The correct answer is A, or whatever version you had. The capacitance of a parallel plate capacitor can do what? Well, I know I have 2 equations. Q is equal to CV, and then also C is equal to kappa epsilon naught A over D. And these describe the capacitance. Now, if I change the charge or the voltage, that doesn't do anything to the capacitance. So I just forget about this one. It's not really important. In fact, that tells me, too, that these two are not important. But if I increase or decrease the charge on a capacitor, that doesn't change the capacitance at all. In fact, that just changes the charge or the voltage. The capacitance is really set by the geometric properties of the capacitor. And so if I increase the plate separation, now what's that saying is that I make D bigger. What does that do to C? Well, if I do that, C gets smaller. So it's not going to be 3. If I decrease the plate separation, as if I make D smaller, if I make this smaller, it's an inverse relationship, so C gets bigger. So 4 is one answer. And what happens if I decrease the plate area? If I make this smaller, then C gets smaller. So that's not 1. It looks like it's only 4. So D is the right answer for number 2. Number 3, parallel plate capacitor initially has a voltage of 10 volts and is disconnected from the charging battery. When I say that, that means I have a constant charge. So the charge, you put this charge on this capacitor, and then you unplug the battery, and whatever charge is on that capacitor, it stays on the capacitor. It doesn't have anywhere to go, and it doesn't have any battery to put more charge on it. If the area of the plates is now doubled, what is the value of the new voltage? So Q is equal to CV. I know that this is constant. If I double the area of the plates, if I double A, I double C. So if I double C, if Q is constant, that means my voltage is halves. It was originally 10 volts, and now it's going to be 5 volts. In open heart surgery, a much smaller amount of energy can be used to defibrillate the heart than external defibrillation. What voltage is applied to the 4 microfarad capacitor of a heart defibrillator that stores 30 joules of energy? I know that, by the way, this is like a, defibrillator, you have those paddles and you rub them together, clear, but this is not talking about, it's talking about where you're in surgery and your heart starts pumping. You have to apply a voltage to the heart, inside the chest. It doesn't require as much voltage. So I know that energy is 1/2 CV squared. I'm looking for V. I know C is 4 microfarads, so I have 30 joules equals 1/2. This is going to be 4 times 10 to the minus 6 because it's in farads, and V squared, 60. I get 39 or 3870. So V is 3870 volts. So number 4 is A. That's still a lot of voltage. All right. Each of these capacitors are 4 microfarads. What is the equivalent capacitance of the circuit? So I have 4, 4, a 4, a 4, and a 4. Now recognize that these two circuits are the same. 4, 4, 4, 4, 4 microfarads. And then recognize that these two 4 microfarads in series are equivalent to 2 microfarads, 1 over a quarter plus a quarter. So this is 2 microfarads. So I have a 2, a 4, and a 2 in series. So in parallel, rather, that's 2 plus 4 plus 2. That is 8 microfarads. So number 5 is B. What's the potential across the top left 4 microfarad? Okay, I want to know the potential across this one. I can redraw this. You might not have to redraw it, actually. You might be able to just tell. I redrew it, and I'm going to combine these two now to give me a 2 microfarad. Remember, that's 1 over a quarter plus a quarter. That's equal to 2. And then I have 2, and I have 4 here. So I have a 4 and a 4 with 12 volts. Because these are identical capacitors, I'm going to have 6 volts and 6 volts. And that means I have, let's do a different color here. That means that I'll have 6 volts here, 6 volts here, and 6 volts here. Now, because these two capacitors are identical, they each split up 6 volts. So that means I have 3 volts and 3 volts. So the answer is 6 is B. Consider this circuit. What is the magnitude and direction of the conventional current through the resistor? I know conventional current runs in this direction, so it's got to be clockwise. And it's just a matter of finding the magnitude. I know I is equal to V over R. 4 over 2, that's 2 amps. So C is 7. The terminal voltage of a battery is always smaller than the ideal EMF. So if we go back to here, like I have a certain voltage here, but if I think about my battery, like if this box represents my battery, there's actually another resistor there. So while I might have 4 volts across this battery, I might lose a volt here so that I only get, say, 3 volts that's usable voltage, my so-called terminal voltage. So all batteries have internal resistances, although a lot of work goes into decreasing that internal resistance as much as possible. And that causes your terminal voltage to be smaller than the ideal EMF. You wish to measure a voltage across a resistor, you should connect the measuring device in what way? In parallel. You should have just known that. So, although many of you have done that in the lab. The battery has an ideal electromotive force of 12 volts. When force of current is driven by the battery, its terminal voltage is 10 volts. What is the internal resistance of the battery? All right, so 12 is my EMF, and then I have my internal resistance, and I'm told that I have 4 amps. I call this little r. And actually, I don't know what the external resistor is, so I'm just going to imagine that I just have this, and I know that when I measure the voltage across here, I get 10 volts. That's my terminal voltage. And so 10 is equal to 12 minus I times little r. And I want to know what little r is. So 10 is equal to 12 minus 4 times r. So r is a half an ohm. So number 10 is A. For 11, 100-watt device requires 150 volts potential. What current goes through the device? So I know that P is equal to VI. 100 watts equals 150 volts times I. So I is 100 over 150. What's that? 10 over 15, 2 over 3, 0.67. So 11 is A. If you increase the voltage across the resistor, what happens to the resistance? Nothing. This is, even though I have Ohm's law, V is equal to IR, that R for resistor is going to be constant. And if I increase the voltage, I'm not going to increase the resistance, I'm going to increase the current. We had a similar thing like with capacitors, that the resistance is set based on the material, the type of material, and the geometry of that material, the length and the cross-sectional area. We see that here. So I want to be able to select the material. This is a nice way, if you have an unknown metal, to determine the type of metal that it is to apply a voltage, measure the current, measure the dimensions, and then calculate the resistivity. So let's do that. R, I know, is equal to V over I. That's from Ohm's law. V is, what was V? 30 over 10. So I have 3 ohms. And I know that R is equal to rho L over A. I want to solve this for rho, so R A over L. That's 3 ohms. A is 1.63 times 10 to the minus 8. And then L is 3 meters. Let's see, I think I might have changed this. Yeah, I changed this one. I'll come back and fix this later. Let me just see how I changed it. Yeah, I changed this actually so that the length was not 3 meters, but 2 meters. That changes it down here to 2 meters, and that gives you a resistivity of 2.44 times 10 to the minus 8 ohm meters. And then you go through here, which of these is going to be gold? So C is the right answer. 2 pieces of copper wire, the same diameter. The length of wire A is twice that of wire B. How do the resistances compare? Well, I know that R is equal to rho L over A. If I increase the length, I increase the resistance. It's just harder to push electrons through a longer piece of wire. It's just more material to push it through. And so if I do that, RA is going to be twice RB, because A is the longer wire and B is the shorter wire. So here I have the bigger resistance and the smaller resistance. What's the equivalent resistance of this circuit? So I can redraw this circuit. I have a 2 ohm, a 6 ohm, and then I have this thing where I have 2 parallel branches. Same one, very similar to this. And I want to know the resistance of it. That's 2, 6. This is 2 and 2 and 3 and 6. And the 2 and 2 in parallel, this is equivalent to a 1 ohm, and this is equivalent to 2. So I have a 3 ohm resistor down there in the bottom because I do 1 plus 2 equals 3. And now I have a 3, a 6, and a 2. So I have to find 1 over 3 plus 1 over 6 plus 1 over 2. I think we've done this. Let's see, that's 2 over 6, 3 over 6, 3 over 6 again, 6 over 6. So it's B, 1 ohm. So 15 is B. Alright, which of these resistors has the lowest voltage? But notice I don't give you this. You can't work it. I mean, I guess you could just make it 12 volts or whatever and work it out. But let's just think about it. I have a 6, and a 2. Actually, no, I don't even need to do that. Actually, let's hold on just a second. I need to think about this. Okay, sorry about that. So I'm going to make a small change here. I'm going to make this a 1 ohm resistor instead of a, what was it before, a 3 ohm resistor. And then, if you notice here, I have a 6, a 3, and a 2 ohm resistor. But I just did a 6, 3, and 2 in parallel. So we know that these two are 1 ohm and 1 ohm. So both of these are 1 ohms. That means that they both have the same potential. Like, for example, if this was 12 volts, then both of these would have 6 volts. And so I have 6 volts here, and then across this entire thing I would also have 6 volts. And so these two resistors are going to split up that 6 volts. And the one with the smaller resistor will have the smaller voltage. So that's the answer is C, R3. Which of these equations is correct? Okay, so I just start with this one, minus 2 plus 2i2. Where's the minus 2? That would be right here. I'm going to be going in this direction. Plus 2i2, that's correct so far, plus 4. It would be correct, except I don't have this 1 ohm resistor, so that one's not right. Let's look at this junction rule. Junction rule says IN equals I out. Let's just pick a junction. Here I should have I1 is coming in and I2 and I3 are going out, but that's not what that says, so it's not right. This 2 minus 1 I2, so starting here and going in this direction, 2 minus 1, no, because that's the wrong current, so that's not right. 2 minus 1 I1, oh, this is similar. 2 minus 1 I1, that's right so far. Minus 4, okay, that's okay, because I'm going from high to low. Minus 2i2. Oh, we got a winner. That should be it. Let's just check this last one. So I have 4 minus 2i2. Well, the minus 2i2 is right, but this should be minus 4 minus 2i2 plus 2i3. So that one's not right. D is the right answer for number 17. What's the current I2? I like this one. So, I can just start filling in things. There are a couple ways you can go about this, but let's just fill in all the currents because then you'll see it more readily. So I know that this is 2 amps because I have 6 amps coming in here and I have 8 amps going out there. So that must be 2 amps. And then if this is 2 amps and this is 3 amps, then that must be 5 amps. And if this is 8 amps and 3 amps, then this must be 11 amps. And notice here it matches up because here I have 11 amps. Oops. And I have 5 out, 6 out, so that adds up. But I'm looking for what? I2? Yeah, so it's going to be 5 amps. A. So A is number 18. And then 19. Which of these rules for resistors in parallel? They must have the same current. Nope. They must have the same voltage. Their current can be the same, but only if the resistors are the same. As you add more resistors in parallel, the equivalent resistance decreases. Weird but true. Yes, that's true. As you add more resistors in parallel, the total current increases. True as well. For resistors in parallel, the equivalent is always less than the smallest resistor. That's true too. So 2, 3, and 4 are both correct, are all correct. So D is number 19, and then finally number 20. I know that the voltage across here is 6 volts. What's the output voltage of the battery? A couple ways you could do this. Well, I know if this is 6 volts, this must be 3 volts, right? Because it's half the resistance, so it has half the voltage. And then this must just be 6 plus 3, or 9 volts. So number 20 is A. I guess if you really wanted to get more rigorous, you could say, well, the current here, I is equal to V over R. That's 3/2 of an amp. That means I have 3/2 of an amp going across 6 ohms of resistance. So if I draw my equivalent, I have 6 ohms, 3/2 amp. So V is equal to IR, which is 3/2 times 6. That's 9 volts. So A is the right answer. And then that's the end. Good job.